Hey folks, I want to in class, if you were gone, I guess you're watching this video, or if I didn't make it clear in class, that um, when we have this situation going on, we have a y value, and then we have the rate at which the y value is changing. And if you take the rate at which it's changing divided by the y value, you get a constant amount. Well, that means that the derivative divided by the original function gives you that constant, or the derivative equals the function times the constant. That means you have a directly proportional situation going on. Now, maybe those words overcomplicate the situation, but what we have is something like this. We have a derivative equal to a constant times the original function. And after you separate the variables and do a whole ton of work to it, you end up with an exponential function that looks like this. So in my homework problems, I might suggest that you skip all the separating the variables and you go right down to the exponential function that you really want to mess with. So let's see if we can make that clear on a homework problem. Now, I attach these notes as a PDF, but I think it is hard to see them. You got to zoom in and all that kind of stuff. But hopefully, if you were gone in yesterday's discussion, you can get some notes down. And you might need some help from me on how did this work? How did we separate the variables, take the antiderivative, and all that kind of stuff, and get to this conclusion? Well, so in our problem that we're going to do, it's number 5 from today's homework. They say that somebody gets poisoned at work by accident. They've inhaled some poisonous gas and they don't feel so good. So 20 hours later, they go into the doctor and they see that they have that concentration level. So at 20 hours, they have a concentration level of 0.00372. Now, I'm kind of getting ahead of myself. See, they're giving us this information so that we can find the constants. What constants am I talking about? Well, we said that we're going to get an exponential equation that looks like this. Y equals y sub 0 e to the k times x, I guess, if we're going to use x, or if you want to use t, you can use t. So I'm just going to put an x down here for just a second. Our two constants that we're looking for is the initial amount. So this stands for the initial amount. And then we're also looking for this number up here. This is another constant, which depends on what situation we have going on. So yesterday we were talking about money. Somebody was making money and it was like a 5.8% return on their money. So this number right up here became 0.058. That was the rate at which the money was increasing. So what we're going to do is we're going to find those two constants. And just to kind of reiterate, right down here is another key piece of information where it says, from biology, that the instantaneous rate of change of the concentration level with respect to time is directly proportional to C. Now, what the heck does that mean? They're telling us that it's dy dx is equal to k times y, where y is the concentration level, y equals C, or concentration level, concentration of the poison, okay? Of poison, and then our x is going to be time. Okay, so I'm just going to use those two variables, y and x, instead of t and c, right? So this might be t and this might be c over here, and I'm going to do that in video 2. Like, how do we find the y sub 0 and the k if our starting amount is after 20 hours, and then it says 8 hours later after this, like 28, the concentration level is down to 0.00219. So I'll put that in video number 2. Thanks for watching video 1 and getting it all set up and seeing a little review of what we talked about yesterday. Okay, thank you.